Okay, so now let's begin. Thanks for coming. This is the first OpenResty Bay Area meetup. Thanks Cloudflare for hosting the space, and thanks for our speakers. And we have a free Wi-Fi here, so I like to ensure everyone has internet. And today, the basic schedule is like this. First presentation is from Marco of Mashape. And they has built something really brilliant upon OpenResty. And the second presentation is from Dragos of Adobe. And they have been using OpenResty to power their Creative Cloud services. And the final one is from myself. And I'll talk about the new features added in the last 3 months or so, and also some plans of the near future. So this meetup will be recorded, and the video will be on internet for everyone to see. Okay, so first one is from Marco. Welcome, Marco.
Okay, so thanks for inviting me. I'm Marco Palladino, the CTO at Mashape. Today I'm going to talk about Kong, which is one of the products that Mashape has built for API and microservice management, and how Kong leverages OpenResty and why it uses OpenResty to deliver its functionalities. First of all, I'm going to give a little introduction of Kong. Kong is an open source management layer for APIs and microservices that manages and extends upstream APIs and microservices you put behind it. So Kong sits in front of any kind of public and private API. Client consumers make requests through Kong, and then Kong executes extra functionality like logging, authentication, plugins for you, and then it proxies the request to the upstream API. Requests then go back to Kong, responses go back to Kong. Kong processes other response plugins that you may have decided to use, and then sends the response back to the client. The use case for Kong is to centralize all the common functionality that people usually build when they create a microservice-based infrastructure. When you have different services, different APIs, different HTTP endpoints, usually building those endpoints is just 50% of the work that's required in releasing an API or a microservice. The other 50%, it's making sure that things like authentication, logging, rate limiting are in place and allow you to make the API consumable from either public or internal client applications. The way Kong works, Kong is built on top of OpenResty, and Kong by itself is just a reverse proxy. It doesn't do any functionality unless you add one of the plugins that are built in Lua that you can add on top of the APIs. Kong itself has a RESTful API, so that means that you can operate Kong with an admin RESTful API, you can add upstream services, APIs, and then decide to add extra functionality on top of it. And all of these plugins are built in Lua and executed inside of the OpenResty application. One of the main requirements for an API gateway like Kong is that it usually sits in front of your internal APIs and microservices, which are mission critical. So one of the main requirements for services like Kong is to achieve high performance and be stable. And the fact that OpenResty is built on top of Nginx, which is a reliable solution, well, that's obviously a selling point for Kong. extendable by leveraging Lua plugins that can hook up into the OpenResty events like Access by Lua, Certificate by Lua, Header Filter by Lua, that can change how requests and response are being processed by the system. Portable, can be deployed pretty much on every Unix system, and I guess Windows, but I'm not 100% sure. And most of all, easy to use, easy to extend, and easy to deliver new functionality on top of the system. So OpenResty has been chosen for our project because Nginx, as I said, it's a very popular server, and from a business standpoint, people are willing to introduce, instead of their infrastructure, a technology that they already know how to use, they already know how to deploy, and they would probably already use Nginx in front of their APIs anyways. So we're not telling them to change how things are built in their infrastructure. They can just get rid of their Nginx machine and put Nginx on steroids, which with OpenResty, and do pretty much the same things, plus having all the extra functionality that can be added with plugins. LuaJIT support, it's exceptional because all the Lua code that's running inside of the Nginx runtime, it's been actually executed by the LuaJIT, which is a very, very fast implementation of the Lua virtual machine, which means that we can do all these additional operations and logics in the life cycle of requests and responses in a very fast way. For example, Nginx has released JavaScript support, JavaScript scripting support for their system, which unfortunately it's not as fast as the LuaJIT. The LuaJIT, it's an exceptional piece of software that it's extremely performant. And community. Although the Lua community and the OpenResty community is still small, it's growing, and so obviously that's a plus one. Lua itself has many projects, not as many as the other languages, but it's growing again, and the community is usually very responsive. So that's obviously a plus one. The main components of Kong are described in this slide. Kong opens two different ports. One is for the admin API, and one is for the actual proxy functionality. So people can, client consumers can consume APIs through the proxy port, which will execute every plugin the user has decided to install on top of the API. And the plugins itself will leverage the OpenResty API to change requests, response, and do any kind of logic that needs to be done. And that's done by hooking into the OpenResty events like Access by Lua, Header Filter by Lua, Body by Lua, Log by Lua, etc. It also leverages, provides a CLI system to pretty much do every operation to control Kong and the service. The API, by the way, it's provided by Lapis, which is like a very nice web framework built in Lua. It's very young, but it's like, I guess, the most popular Lua web framework, so it's very nice and easy to use. Well, so I had 5 minutes, so I make this presentation very short. Thank you for listening, and let me know if you have any questions.
Do you have any experience to share, like going to review the whole structure what kind of bottleneck you managed
One of the biggest problems is making sure that every functionality that's being executed runs very fast and it's not blocking. So for most of our functionalities, like interacting with third-party data stores or third-party services, we're leveraging the co-socket API instead of OpenResty, which it's non-blocking. This means that we can keep accepting incoming requests without blocking the process. And I guess that's one of the main concerns, being able to avoid blocking the main process, the worker. Well, Kong, at the end of the day, it's think of it as a web application. So benchmarking Kong is setting up the environment. Kong relies on a data store for storing configuration, plugin execution information, Cassandra and Postgres, which is going to be released very soon in a couple of weeks. So benchmarking the system means setting up a proper database with the proper configuration, default configuration, Kong on different servers. Kong wants more CPU power than memory because to process all the incoming requests. So it's the more CPUs are better. And this is like fundamentally a property of the underlying Nginx runtime. And so we just simulate thousands of requests going through Kong and then hitting an upstream service and demonstrate and try to track how big is the latency in executing all the Kong plugins and measure the network latency and then exclude the network latency in order to see exactly how long does the process take to execute all the functionalities. Yeah. All right. Thank you.